Okay, we're back on again. Once again, any questions may go on the internet. So, wow, not a good typing start. And so then we would put in address of A. And that's literally how you read that, address of A. And then if we compile it and run it, then it says the value is 4 and the location is 0x7FFF, blah, blah, blah. So let's do another one. Sorry, that went fast. Let me try again. Now we've got two integers, A and B. We've set them to have different values, and we have print statements for A and for B. By the way, the reason I'm filming this is because I'm going to put it on YouTube. So you're welcome to take any pictures, but this will be posted after class. So now, if we run it, we see that A is 4, B is 8. The location of A is this monster. And I'm just going to focus on the last two, 9C. B is all the same stuff, but then 9-8. And so one thing that we know is in terms of the memory addresses, it's actually counting down. So this is automatic memory, which means it appears on the stack. And the stack actually starts with the highest memory address, and then it goes down and down and down and down. One of the things we'll learn about later in this lecture is the heap starts with the lowest memory address and goes up and up and up and up. It's impossible for them to meet in the middle. That's bad, okay? And so this is starting with a high number and it's going down, and then we're probably not so great at hexadecimal yet, but C is 12 in hexadecimal. 12 minus 8 is 4, and what that means is it allocated 4 bytes for the integer, and then this was the next available location. And presumably, B occupies its 4 bytes would be 9.8, 9.7, 9.6, 9.5. So if we made another integer, we would expect it would be at 9.4. Let's do that. So now, let's see, I'm going to join these two lines. I could just do this. And we'll set C equal to 5. By the way, so for those who are getting good at VI, so I did YYP, and that did a copy paste, and now I'm searching for B, and I do an R to do a replacement. I replace it with C, and then I search again for B, a dot to do the same action again, and it's just fast, right? So remember we talked about VI is all about efficiency. And if we run it, now we have the expected thing that A was still at 9C, B was at 9.8, and C is now at 9.4. This is not a guarantee. It does not have to work this way. The compiler has flexibility in how it lays out the memory. If we had changed the order and said that we wanted C, A, B, it would be reasonable to assume that now that C comes first and then A and B, that C would be at 9C, A would be at 9.8, and B would be at 9.4. But it doesn't have to be. The compiler has flexibility. Now for a trivial case like this, it's almost certainly going to be that. Let's compile and run and see what we get. So now, as we suspected, C was at 9C, A was at 9.8, and B is at 9.4. And so the order of declaration in this case affected the memory layout. Where you'll really see this, where the compiler will really change from what your expectations are when you get declarations of variable sizes. So for example, if I had put in unsigned cars, And now I'm printing the locations of each of those. Let's cat that program, and I compile it. I have not run this beforehand, but I'm willing to bet that F and G will be laid out right next to D and E. Okay, so let's try it and run. So it looks like I got it wrong. So here it's given 9F and 9E to D and E, 9.4, 9.0, and 9.8, or 9.8, 9.4, 9.0 to C, A, and B. And then it's gone down to 8F, which is immediately below 9.0 for locations F and G. So what that means is the 2 bytes in here are being orphaned. Some compilers, if it sees 4 unsigned cars, will try to get them all together. And there's something that you'll learn in 3.14, which is for integers, which are 4 bytes, it wants them to lie along even multiples of 4, 0, 4, 8, C. And so that's one of its principles, because that optimizes the use of the computer architecture. And so when it has single bytes like unsigned cars, it tries to fit them in. This compiler didn't do it. Okay, I think I'm going to stop this video unless there's any questions about this. I will say before I stop it, trying to predict where the compiler lays out memory is a fool's errand, and so that would never be a test question, but at the same time it's good to build some intuition about what it's doing. In particular, one of the things we'll learn, and we'll talk about in the next video, is if you have an array and you're trying to write to element 0 and 1 and 2, and maybe there's only 3 integers, and you go and start writing to 3 and 4 beyond where you're supposed to be writing, you're going to be actually writing into other memory locations, and that's going to be a problem. And so having some intuition about how the compiler is going to lay out memory is good. And I encourage you to write programs like this and to run little tests about where it's laying things out.